The objective of this video is to practice using our newly developed winding layout design approach to practice laying out a single layer winding. So consider an example, single layer 3-phase 24-slot winding with 4 poles. Suppose that you are told that you need to construct a winding layout for this. First, I want you to calculate the value of Q, alpha U, and Y. If you're not quite sure what these terms mean, hit the pause button now, look them up, and proceed to calculate. Press play when you're ready to watch me do it. So lowercase q is your slots per pole per phase, and that is going to be equal to 2. And this means that when you draw your star of slots, you're going to have 2 phasers per zone. Alpha u is the phase angle spacing between adjacent slots. And to calculate this, we need to start by calculating alpha c, where alpha c is the spacing of our slots. And the spacing of our slots must be 15 degrees, and alpha u is going to be equal to that times our number of pole pairs. So alpha u is an electric angle, whereas alpha c is a mechanical angle. So our star of slots is going to consist of phasers drawn at 30-degree angles. And next we need to figure out what y is, and y is our coil span for a single layer winding. Using the approach that we've taken so far, it's going to be a full pitch winding. You could make it short pitch, but in our standard design procedure we had to do this as full pitch coils, and that we've shown is just equal to m times q. So next, I want you to draw the star of slots and assign the phasers in the star of slots to the different coil sides, or the different phases of our winding. So this should say phases of our winding. Press pause now and press play when you're ready to watch me do it. So you can see that I've drawn our phasor diagram with 30-degree spacing between slots, between slot phasers, and then I've assigned these 60-degree phase bands or zones on top of it in the sequence that we described in our video lectures. And we can label the angle of each slot if we want. Finally, I want you to draw the winding layout schematic for phase U. Press pause, give it a try, and press play when you're ready to watch me do it. Okay, and we can see that we have current flowing down in coil sides 1, 2, 13, and 14, and returning in coil sides 7, 8, 19, and 20. And this indeed matches our coil span of 6 slots, going from slot 1 to slot 7, slot 2 to slot 8, and 13 to 19, 14 to 20. And coming back up out of slot 8, the next connection should be over here at slot 13, and we're going to repeat the same sequence that I just sketched in slots 13 and 19, 14, and 20. And that's because, if you look closely, this winding repeats itself after 12 slots. So we can say that the first 12 slots represents what's called a base winding. That's the periodicity of the winding. That's the smallest repeated component of our winding. We'll be talking more about base windings later. So we can sketch the same thing again over here. And we now have completed this example. We have a winding layout for our phase U winding.